PCA is used for dimensional reduction. That's fine. So let's see one example now. So let me assume we have a matrix. Um, Hope you are familiar with this. So this Z is going to be the n cross P matrix defining the transformation, and this is going to be the X is going to be my actual data set. This is going to be the n cross P matrix of n observations on P variables. So P variables means the P columns, right? P columns, and n observations are going to be the number of rows. So we have now, suppose we have a 5 attribute class data set, like marks in mathematics, physics, chemistry, and computer science and biology. We have 5 marks, and then thereby we have we predict whether the student is studious or not, some class attribute. So the dependent variable is um, so the class attribute is the dependent variable, and all these are the independent variables, all the 5 marks, right? So we have P variables. All the columns are P variables, and n is the number of instances. And this A, what is A? This is a P cross P matrix of coefficients defining the linear combination. So this is a P cross P matrix of the coefficient defining the linear combination. Okay, I hope that day we wrote the full expansion of this. Z1, Z2, Z3, all the components with X1, X2, X3, and A1, A2, A3, right? We wrote that on the day. So basically, what are the steps in a PCA? What should we initially do? So given n observation with P data, we need to calculate the deviation. Calculate the mean deviation, and then we calculate the covariance, right? And then we compute so this covariance matrix will be a P cross P matrix. What do I mean by covariance? Correlation between the attributes. P attributes are there, no? So it's going to be a square matrix. For that square matrix, we can compute the eigenvalues and eigenvectors, right? So the eigenvectors is going to show the skewness, and eigenvalues is going based on eigenvalues. You can say how much of how good is an eigenvector is, right? So for that, secondly, eigenvalues and eigenvectors can be computed only for square matrix. Okay, so that's a part of math. So compute eigenvectors and eigenvalues. Choose the principal components. So what do I mean by principal components? So choose the appropriate principal components. So what do I mean by choosing the components? How do I know which component is very good or the goodness of component based on the eigenvalue of the eigenvector? So if the value is high, I can choose some corresponding vectors. For example, if this is my search space, so this may be Z1, this may be Z2, this may be Z3, right? This may be Z4, this may be Z5, somewhat. They may not be purely orthogonal or somewhat. So these vectors may represent the search space, the entire problem space in such a manner. So there are so many components that may be there. So if I have five variables, I may have 5 components, among which I may choose, I can have only Z1 and Z4. That's going to represent all my space. So of course, it is a kind of a lossy representation, but you are avoiding 3 rows, 3 columns of data. So imagine how much of space and the time complexity of your search and the time complexity of the machine learning algorithm you're going to develop, everything will get enhanced significantly. Moreover, if the data is going to be a lot redundant, then eliminating these kind of components is going to be much better, right? So that's the purpose of going for this transformation. So let me start with an example. Um, So this is my two-dimensional data, right? So two variables here are x1, x2. This is my two-dimensional data I have here, right? And for this data, so the mean of x1, so for this data, I need to compute the deviation from the mean. How do I compute the deviation from the mean? Just subtract the each of the attribute value from the mean. So can you do that? So 105 minus 108.5, I'm going to get minus 1.3, 8.7, minus 3.8, minus 12.3. I missed out one value here. 8.7, 3.8 minus 12.3 minus 11.2.3, 13.7. One value missing. Clear with how I got these values? So from this mean, I can calculate the what do I need to calculate? I need to calculate the covariance. Covariance of generally a covariance between two variables x comma y is for all n is equal to 1, I is equal to 1 to n. Oh. X minus x bar, y minus xi minus x bar, yi minus y bar. So this is the general, all these you would have done in your stats, right? So I need to compute the covariance matrix. That's going to be covariance of x comma x. That is covariance of x comma x is nothing but the variance of x comma y, y comma x. Right? I need to compute this. So for my given problem, I've already done it. So it turns out to be this is my covariance matrix. Right? So using this for this covariance matrix, I need to compute my eigenvalues and eigenvector. Hope you remember the slide presentation on that day which I showed you on PCA. Like we had that arrow and the covariance matrix and the transformation that we do from here to here is on the covariance matrix is what is going to be the transformation of the data points in this domain to the other transform domain, right? So computation of eigenvalues and eigenvectors, you can find the characteristic equation of this, and then you can solve it using any online solver, or it's not a big tough, just a 2 cross 2 matrix. So you would get the two eigenvalues to be and the corresponding eigenvector x will be so these are the two eigenvectors, and by the way, eigenvectors are unit vectors, right? So the distance is one. You can even see, for example, this is one eigenvector, right? So how do you see that? 0.801 root of 0.01 whole square plus root of 0.59 whole square, you'll get equal to 1. So, so how many components do I need to choose? Here, of course, just for the ease of learning this, we have used only two variables. So, so that first we can find the trace of I. What is the trace? What is the trace of S? The sum of the eigenvalues. The sum of eigenvalues is called the trace of S. So you can compute the trace. So the so how good is the first component? So that I can. So how good is the first component or each component? So for example, if I take the first one, it's going to be 322 by 350.3 or 4 or whatever it is. Likewise, for the next one, it's going to be the rest, right? So this tells you how much of data, how much of variability is represented by that component. So if I choose the first component, it's going to represent 92% of my data out of the two diagonals, out of the two dimensions or variables, right? So for all the principal components, if you have a 5 cross 5 covariance matrix, then you have 5 eigenvalues and eigenvectors. So how good is the eigenvector? How much of information you get from each of the eigenvectors? You can evaluate by using this method. You can take the trace, that is the sum of all the elements of the sum of all the eigenvalues by the for each value by the total sum of the eigenvalues. This one. So this lambda j is j can be from 1 to p. J is not 0. So from 1 to p, you can vary j and find values of all the j's, right? So now, what is the eigenvector that we have got? So we have chosen the first eigenvector. So this is my eigenvector that I have got, right? So what is my transform data? So this is my data, 1.3, 8.7. So from the mean deviation, I'm transforming this using the vector direction. Okay. Now, a two-dimensional data, we have done a linear transformation and we have represented in a single dimension. Of course, you can represent in two dimension also. It depends on how many eigenvectors you are going to use. So here, since it is 2, I reduce it to 1. If you are having 10 variables, then you have an eigenvector matrix of p cross p, 10 cross 10. And you can use some three variables. Like you can use the first column, third column, and fifth column, and you can transform this entire 10 cross 10 into a uh, 3 cross, sorry, rows, 10 rows and 3 columns, right? By this, you can have it in the transform space. And using this, now you can do all your operations. You can do your classification or regression or whatever problem. You can do it using this transform space, right? Any doubts here about PCA? You have to calculate eigenvalues, and it will be a small. If the sum is given, it will be a small sum only, not such a big sum. Also, you'll have a small thing like a covariance of 2 cross 2 variables. 2 variables are maximum 3. right? So it will be computable. I think 3x3 value variable you can compute it by hand, right? And of course, you all have your systems. Any questions on PCA? Okay.